Alright, and welcome to Quadratic Inequalities Level 1. Now, in example 1 it says solve for the solutions to the following quadratic inequality. f of x is less than x squared plus 7x plus 12. Now we're going to solve these very similarly to a quadratic equation, where we have an equal sign, and the differences really just come in at the end. So when I look at this, I notice a couple things. Firstly, I notice that my a value is 1, so if it's an a value of 1, I can always try simple factoring, okay? And then the second thing that I want to do, and this is where it gets a little bit different, is, well actually I'm kidding, it's the same. We still want to set f of x equal to 0, so we're going to change that to a 0. But this is the tricky part. We're saying f of x is less than 1x squared plus 7x plus 12. This right here, I want you to essentially think of this as these are my solutions. These are my solutions. And it always makes sense to read things from left to right. So we really want to know my solutions, are they greater than or less than 0? And this is not how the problem's set up. So what we want to do is with a quadratic inequality, we always want to flip this whole thing so that our 0 is on the right. So what do I mean by that? Well, we want to rewrite this as x squared plus 7x plus 12, and see this less than symbol, if I flip the whole thing, less than becomes greater than, and then this is where I change this f of x into 0. So I flip the whole thing, which means I flip the inequality right here, and I change the f of x to 0. So that's going to be our first major difference. Now from here we solve like normal. We say, okay, well, x squared plus 7x plus 12 is greater than 0. How can I factor that? And remember, you're always looking at your c term, and you say, well, what two numbers multiply to be 12 but add up to be 7? And our options are 1 times 12, and 2 times 6, and 3 times 4. But we know that 3 plus 4 is 7. So those were the two numbers we were looking for. X squared breaks up into x, and we have a plus 3, and we have a plus 4. Now from here, very similar to our quadratic equations, we want to know what value of x makes each of these factors equal to 0. So I set them both equal to 0. X plus 3 equals 0, and x plus 4 equals 0. And we can do minus 3, x equals negative 3, comma, minus 4, and x equals negative 4. So these would be normally these would be our two solutions. However, this is not the case for a quadratic inequality. So look at part B to your assignment. So part B says to graph it, and I give you an xy axis. Let's go ahead and draw that. I'll just kind of extend that left side. And so we know that our solutions would typically be, or our zeros are at negative 3 and negative 4. So let's go to the left. 1, 2, 3, and 4. Let's put our point. And since our a value is in fact a positive 1, we can see that from the very beginning, we know that our function is going to open up. So it'll look something like that. Okay, so here is where this makes a lot of sense. We're looking for where all of our solutions are greater than 0. What does it mean to be greater than 0? It means to be above the x-axis. So we know that y is equal to 0 on the x-axis. So we're actually looking for these parts of the graph. We're looking for this part of the graph right here that's above the x-axis, or greater than 0. And we're looking for that part of the graph right there. So right here, this is where the function is positive. That's where the function is positive. And in between these 2 points, in between the two zeros, that's where our function dips down below, and that's where it becomes negative. Okay, so what's that really telling us? Well, let's look at part C. Part C, what I do is I give you a number line, and I think this is where it really helps you write the solutions. So I have right here negative 4, I have right here negative 3, and what you do is you circle your two zeros, and you ask yourself, should they be left open or shaded in, kind of like absolute value inequalities. And since this is a greater than symbol, we'll leave them open. If it was greater than or equal to, we'd shade them in. And then we're looking, like, how would you describe these two red parts of the graph from part B? you would say that they are on the outside of those 2 points. So really what we're saying, oh here, let me show you like this. What we're saying is we're looking for every solution that is to the left of -4 and every solution that's to the right of -3. And then you ask yourself, lastly, well, how do I write that as a solution set? Well, this is an or statement, and so we say this: x is less than -4 because it's everything to the left of -4, or x is everything greater than -3. And so that's how you get to your solutions. And you're thinking like, whoa, that's pretty tricky. Just understand, all the math that you've done is the exact same as solving for quadratic equations, and now it's just a trickier interpretation, okay? So let's go ahead and see a second example to give you a little bit more practice. Okay, here's example 2. F of x is less than or equal to -2x squared minus 10x minus 12. Okay, so a couple of things to note here. One, remember, it's this function right here. This is where we, of course, find our solutions. And we want to have our solutions on the left, and this f of x that we want to set equal to 0, we want to have that on the right. So we really want to flip this inequality. Okay, so let's go ahead and write it like this. Let's say, you know what, we have -2x squared minus 10x minus 12 is greater than or equal to 0. So notice I took my less than or equal to symbol, and when I flipped this entire inequality, the inequality less than or equal to became a greater than or equal to. And of course I changed my f of x equal to 0. Okay, now this is actually what I've considered a level 2 quadratic in the past, because we noticed that our a value is not equal to 0. So recall, your first step is to see, hey, you know what, can I factor out a -2? Or another way of saying that is, can each one of these coefficients be divided by -2? And of course they can. So we can write -2, big parentheses, is greater than or equal to 0. And let's just go through these. -2 divided by -2 is positive 1x squared. -10 divided by -2 is positive 5x. And -12 divided by -2 is positive 6. Okay, perfect. Now from here, now that I have an a value of 1, I can use simple factoring. Okay, so we have our -2, and then let's go ahead and split this up into our 2 sets of parentheses greater than or equal to 0. Now y'all, I know that 6 is pretty easy to break up. We could say 6 is really 1 and 6, or 2 and 3. And which one of those sets of numbers would add up to give me 5? And of course we know that's 2 plus 3. So x squared splits up into x, and we have x plus 2 and x plus 3. And if you will recall, the way that we solve these is we now set each one of these factors equal to 0. So we have x plus 2 equals 0, we have x plus 3 equals 0, and let's just solve for x. minus 2, and x is equal to -2, minus 3, and x is equal to -3. All right, now recall that those are our zeros, and if this was a quadratic equation with an equal sign, those would be our solutions. However, that's not the case here. So what does this look like if you graph it? Well, this is part B from your assignment. And so let's go to, there's -1, -2, and -3. And I have a 0 at -3 and a 0 at -2, but here I notice something a little bit interesting. I notice that my a value is a negative. We have a negative a value. What does that mean? It means that my inequality doesn't open up, it means that my inequality opens down. So my inequality is going to open like that. Now, what's interesting there is that you'll notice that here, let's use some different colors. This portion of the graph and this portion of the graph are below the x-axis, meaning that that's negative and that's negative. And this portion right here is above the graph, so that portion is positive. So think about this. If we're looking for where our solutions, remember these are my solutions, are greater than or equal to 0, Well, we're looking for where the graph is positive. So we're actually looking for these solutions right here. Okay. So let's go ahead and graph that on a number line. Let's see what that looks like. So part C, we have our number line. We know that our key values, the zeros, are at -3 and -2. I circle both of those. And then I ask myself, well, wait a second, if it's greater than or equal to, should I shade those circles in or leave them open? And of course, we want to shade them in. Shade, shade, shade. Now, you ask yourself, hey, when I'm looking at this graph, where are these positive solutions? Are they in between the zeros, or are they on the outside of the zeros? And you can tell that, hey, this is everything that's in between the zeros. So we shade everything in between. And you'll notice that this gives us a different way to write our solution. This is going to be what you would consider an and statement. We're saying that x, well, here, let's write it like this. -3 is less than or equal to x, which is less than or equal to -2. So we're saying that x is greater than -3 and it's less than -2, but you write it like this. Okay? All right. These should be very similar to your understanding of absolute value inequalities once you get to part C. So really the tricky part is just understanding, like, hey, how do I graph the function? Remember, if it's negative, it opens down, which means that the inside will be positive and the outsides are negative. And if our a value was positive, it opens up, which means that the outsides are positive and the insides are negative. And then you're just kind of comparing it to 0. Are you looking for the values that are above 0? In this case, it's the outsides. In this case, it's the inside. Or is it less than 0, in which case you're looking for the outsides here or the inside there? All right, I hope that this helps. And if it's still unclear, try it out. And when you get to the level 2 video, I think seeing this again after you try this out will be much more helpful. Thank you.